All right, welcome guys to today's lesson. We're going to look at solving some systems of linear equations using substitution. Remember last week we started at solving these systems by graphing, and we were looking for the types of solutions being one solution, no solution, or infinite solution. So it gave you that visual. Well, this time we're doing substitution. We're actually going to go back and we're going to start doing it algebraically, where we solve and move some numbers around and solving for variables. Remember on these we're looking for a solution, again, one solution or no solution or infinite solution. So remember, when we're looking for one solution, that means I'm going to have some kind of solution that gives me an x coordinate and a y coordinate to where I know exactly where my lines are going to cross. So that would be my one solution problem. And then if I look at a solution where I come out with something like 4 equals 2, well, remember we talked about that is a false statement, which means I will not have any solutions, which will be no solution, not zero. Now remember, this is no solution. There is a difference. Okay. And then if you come out and you solve all your problems with something like 4 equals 4, well, if 4 equals 4, well, that would be a true statement, right? So we're talking about this is a true statement. So in this case, everything I put in for x is the same as y. So this one would be my infinite solution problems. Okay, y'all give me just a second. Okay, these will be my infinite solutions. So that means anywhere I put the answer or anywhere I put into the problem would make both of my solutions correct. Okay, so this is my infinite solution problems. So let's just go ahead and jump in and see what it looks like. Well, let's say if I give you this system. Here's my first system. The value of y is -2. Well, the other system, the other equation is 4x minus 3y gives me 18. Well, if I'm looking up here, when we talked about doing this, what I'm looking for a variable. I'm trying to isolate a variable. I want a variable by itself on one side of the equal sign so I can plug it into the other one. I can substitute it. Okay, well, if I look here, my x and my y are on the same side of the equation, so I really can't do much work with that one right now, not with substitution. So what I want to do is I want to look at the other one. Well, the other one is telling me the value of y is 2, right? The value of y is 2, so that's telling me in the other equation, wherever there's a y, I can plug in 2. Okay, and that should give me the solve for x. If I'm plugging in for y, I'm really solving for x. Okay, so what we're going to do is we're going to take the -2 and we're going to plug it in right here for this y. So we have -3 times -2, and then we're going to just substitute it in and finish the whole rest of the equation. Well, now remember my three verbs: distribute, combine, divide. So we can distribute right here. So I have 4x. -3 times -2 is a positive 6, and 18. Well, I'm still wanting to solve for this x, so I need to move these two away from it. So let's get rid of this 6. Okay, we want to get all of our variables on one side and all our constants on the other. This is going to cross out, so I'm left with 4x is equal to 18 minus 6 is 12. Well, again, I want to continue out. So we have distributed, we've done our combining. Now let's do our dividing. Remember the three verbs, okay? So if I cross this out, I have x is equal to 3. Well, for my solution, I know the 3 is part of the solution. Well, it already gave me the y, right? Already gave me the y, so the y is -2. So my solution for this system is 3, -2. And we can check this really quick by plugging it back in. Well, if I plug in a 2 right here, -2 does equal -2. So it checks here, correct? All right. Then if I want to check down here, let's plug in our x and our y. Well, 4 times 3 is 12, minus 3 times -2. Well, -3 times -2 is a positive 6. So 12 plus 6 gives me 18. So it would check here. Okay. So that's all we're doing, just take them and plug them in. All right, let's look at another one. This time, instead of giving you the y, I'm going to tell you that x is equal to 6. All right, the other equation is 3x minus 4y is equal to 22. Well, remember in the last one, we substituted it in for x, right? Or for y, excuse me. Well, this time, remember, we're going to look at this one. Now it's giving me the value of x is 6. Well, I'm going to take this 6 and I'm going to plug it in right there. Okay? So I want to get rid of that so I can plug it in. So what we got now is 3 times 6 minus 4y gives me 22. Well, if I look, now I can distribute here. I have 3 times 6 is 18 minus 4y gives me 22. Well, I'm trying to isolate this y by itself. So what I need to do is let's move this 18 to the other side. So I have negative 4y. And then 22 minus 18 is 4. Okay? And then we're going to divide by negative 4. Divide by negative 4. I should have y is equal to negative 1. So my solution, x is 6. It gave it to me right here. And my y is negative 1. Okay? So my solution to that system, and again, we can check it. Well, 6, if I plug in 6 here, 6 equals 6. And then let's plug it in. 3 times 6 is 18. So minus 4 times negative 1, because my y is negative 1. So negative 4 times negative 1 is positive 4. 18 plus 4 is 22. So it checks here. So it's just remember, all these can go back and check your work. It makes it easier for you. All right, well, what if I give you one of these to where it's actually an equation and it's not just a number? So I'm actually going to give you two full equations now. So what if I give you, let's see, y equals negative 3x plus 5. And the other equation is, in standard form, 5x minus 4y is equal to negative 3. Well, if you'll look up here real quick, I notice that I have one that's already solved. I have a variable that's by itself. It's already isolated, so I don't have to worry about moving anything around at this point. All I need to worry about is where do I put it? Well, here is negative 3x. It's the value of y. So I'm going to plug it in. I'm going to substitute it right here for that y. So we're going to write it out. 5x minus 4 times negative 3x plus 5 equals negative 3. Well, now we kind of got a little work to do, because now we got to look at my three verbs. Well, here's my distribute. So 5x minus, well, so now we've got two signs here. Both of these are negative, so that's going to change it to a positive. 4 times 3x is 12x. Well, I have a minus 4 and a positive 5. That means my distribute is going to result in a negative 20 equals negative 3. Okay, well, remember, we like to do boxes and circles. Remember, we have a box here, we have a box here, we have a circle, and we have a circle. Remember, we put boxes around variables and circles around integers, right? Okay, so let's combine now. So 5x and 12x is 17x minus 20 equals negative 3. Well, here I have my box. It's already isolated. There's no more variables. All of my variables are on the same side, so we're going to move this negative 20. Let's get rid of this guy. And the opposite of negative 20 is plus 20, right? Guys, I do apologize for this pen. I don't have any idea why it's doing this, but just bear with me. Okay, so I have 17x is equal to, well, now my signs are different, so 20 minus 3 is 17, and 20 is bigger, so I'm going to keep the sign of the bigger number. Well, let's get rid of this last part by dividing by 17. So x should give me a positive 1, right? Alright, so what now? I know half of my solution is a 1. Well, I need to find the y value. Well, in this case, it's really simple as far as this. You can plug it in either place. I can plug it in for this x, or I can plug it in for this x. Well, there's a little more work if I plug it into that second one. So this one right here, look at here. The value of y is equal to negative 3 times x plus 5. Well, if I plug that in, if I take that equation, okay, if I take that equation, y equals negative 3x plus 5. Well, if I plug in the value of x, I have negative 3 times 1 is negative 3, plus 5 is 2. So my solution for this system is 1, 2. Okay? And we can go back and check our work with this if we needed to. 5 times 1, here's my value of x, right? My value of x is 1, and my value of y is 2. So 5 times 1 is 5, minus 4 times 2 is 8. So 5 minus 8 is negative 3, and it checks. And we know this one's checked because we just did it. Okay? So we're good with that one. All right, let's go to the next one real quick. What if I want to do something? What if I change it up a little bit? We've been working a lot with finding the y value. What if I give you an equation where we need to solve for the x? What if I give you an equation where x is given? Okay, so we can do the same thing. Nothing's going to change. It's still the same steps. So if I put this equation in, right? All right, so now in this case, the difference here is I have x by itself, and here's my x in this equation. So all I'm going to do is I'm going to take this part right here and I'm going to substitute it in here. So I have negative 3 times, now x is gone, so here's my x right here. Negative 5y minus 17 minus 3y equals 3. And all I've done, guys, I want to look, all I've done is rewritten this equation, and I took out the x and I substituted in the value of x from the first problem. Well, now we can come right here, and now we can do our distribution of the negative 3 to the parentheses. Okay, so now we can distribute here, and we can distribute here if this pen will let me do what I need to do. So what I have is negative 3 times negative 5 is a positive 15y, and a negative 3 times a negative 17 is a positive 51 minus 3y equals positive 3. Well, now I can do some combining. Here's two like terms. So 15y minus 3y is 12y. Well, I haven't done anything to the 51, and I haven't done anything to this 3. Okay, so we got a little work left to do. We're not quite there yet. Okay, so let's go over here now. Let's move this 51 to the other side, because remember, we're trying to isolate right there. That's what I'm wanting by itself. Okay, but first we got to get rid of this one, and then we got to get rid of 12. So this is going away. So I have 12y is equal to, now 3 minus 51. Well, if you remember your integer rules, signs are different. So 51 minus 3 is 48. And since 51 is bigger, we'll keep that sign. All right, and then the last step here is to divide by the number in front of y, which is 12. So I have y is equal to negative 48 divided by 12 is negative 4. Okay, a lot of work in it just to get two numbers. All right, so we have negative 4 here. So there's my y value. Now let's find the x. Well, what I can do is I can go back to either problem, but if you'll look right here, it says the value of x is, that's all I'm going to do is take and plug it in right there. Okay, so what I have is x is equal to negative 5 times negative 4 minus 17. Well, x is going to equal negative 5 times negative 4 is a positive 20 minus 17. That gives me x is 3. So my solution is 3, negative 4. So one solution, 3, negative 4. And again, we can go back and check all these. If I put in a negative 3, so I'll put in a negative 4 right here. Negative 5 times negative 4 is 20 minus 17 is 3. When I put in negative 4, I should get out 3, which is what I did. Now here, when I put in my 3 and my negative 4, I should get out a positive 3. Negative 3 times 3 is 9, minus 3 times negative 4 is a negative 12. So negative 9, I'm sorry, excuse me, positive 12. So negative 9 plus 12 is 3, so 3 equals 3. So this solution does check for both of those, okay? So you see how we're working these? Now, a couple of these I want you to really, before you start solving them, after we start doing this, I want you to kind of pause the video. See if you can do it without me talking you through it. I want to just, and try it, and then start the recording back, okay? All right, let's see what we got here. Let's try this one. What if I give you, now what if I give you one where neither of the problems have been solved for a variable. In other words, I'm going to give you two of them that are in that are in standard form, and we got to do a little work. Okay, so we have negative 5x plus y equals negative 2. Negative 3x plus 6y equals negative 12. Well, remember the first thing we talked about, I want to look, do I have a variable that is isolated on either side of the equation? Well, if I look on the left side, x and y are both of these on the same side of the equation, so I don't have anything that's isolated. Well, the next thing is we look for that lonely variable. Remember, the lonely variable is the only one that has a 1 in front of it. Well, here it is. I can do this later. We're going to do elimination next week. What I want to look at here is right now I know I can solve for this one. So what I'm going to do is let's just bring it right down here. And what I want to do is I want to solve this for y. So I'm going to move this 5x to the other side. So I have 1y is equal to 5x minus 2. Alright, well now guys, this is a positive one, so really don't need to do this next step because it's not going to change anything. But remember, we've worked hard on remembering to divide by whatever's in front of that variable. So we're going to go ahead and we're going to carry it on out and keep our pattern the same. So we have y is equal to, because this is going to cancel, 5 over 1 is 5, and then negative 2 divided by 1 is negative 2. Well, now I have a variable isolated, so now I can do a little work. Well, I want to take this guy now and I'm going to plug it into the other equation right where there's a y. There it is right there. So we're going to come right up here. Negative 3x plus 6. We're going to take out the y and we're going to plug in 5x minus 2. Let me fix that 2 right quick. 5x minus 2 is equal to negative 12. Don't forget, and this is sometimes where you'll make the mistakes right here, is not watching your signs. Okay. All right. So now we've got everything substituted. We plugged it in. Now let's remember our three variables: distribute, combine, divide. So we have negative 3x. Positive 6 times a positive 5 is plus 30x. Positive 6 times negative 2 is a negative 12. Okay. Is equal to negative 12. Well, if I combine these, this is a box, right? And a box, and a circle, and a circle. Well, if I combine these, I get 27x minus 12 equals negative 12. Well, here we're trying to isolate this variable, so let's move this 12 to the other side by adding the opposite. So the opposite here, where I can cancel that out and cross it out. Well, what I have is 27x equals negative 12 plus 12 is 0. Now, please don't be tempted to stop right here and say that this answer is 0 right now, because we still have a number in front of the variable, which means I need to get rid of that 27. Well, in this case, it does work out where 0 divided by 27 is 0. So half of my solution is 0. Now we just got to find the other half. Well, here's the thing I like about this one. Now I need to know what y is. Well, I can plug in this 0 here. I can plug in 0 here. But if I come down here, I look down here, and I notice that the value of y is equal to 5 times the value of 0. So what I'm going to do is I'm going to take this 0, and I'm going to plug it right here. So I have y is equal to 5 times 0 minus 2, which gives me 5 times 0 is 0, minus 2 is negative 2. So my solution is 0, negative 2. Okay? So you see, all we're doing is manipulating around, solving and plugging in and looking for the different variables based off of what we're trying to accomplish here. Again, we were trying to solve this one for y, and then we plugged it into the other one to get our solution. Okay? All right, how does that work? Good. Okay? All right, on this next one, I'm going to do two more, and then we're going to call it a day. Okay? Well, sometimes we have special cases. Remember, the special cases we were looking at are either the no solution problems or the infinite solution problems. And y'all know I can't draw that real well. But anyway, here it is. So let's look at one of these. Let's see what it looks like. So here's my system. Let's see which one it comes out to be. So I have x plus 7y equals 7. And then I have 2x plus 14y is equal to 4. Well, if I look, Again, the first thing I want to ask myself, do I have a variable that's completely isolated? Well, no, because both of my variables are on the same side. Okay, they're on the same side here. They're on the same side here. So again, I got to come up here and I need to find the lonely variable. Well, if I notice, there he is right there. Okay, so I'm going to solve this top problem for x. So what I'm going to do is come right down here. 1x plus 7y is equal to 7. Give me just a minute. 1x plus 7y is equal to 7. Okay? All right. So I'm going to solve for this. So that means I need to move this 7y to the other side. Okay? We're going to cross that out. So I'm left with 1x is equal to negative 7y plus 7. And again, just because this is positive, I really don't have to do this next step because it's not going to change anything. But we're going to stay with what we're used to doing. And so that means get rid of it by dividing by whatever's in front of that variable. So I have x equals negative 7y plus 7. Alright, so now I have a variable isolated. So what I can do with this guy now is I can take this guy right here and plug him into the other equation, but I'm going to plug him in this time right here where the x is at, not the y like we did last time. Okay, so what I have is now I have 2 times negative 7y plus 7 plus 14y is equal to 4. Alright, well, let's do our distributing. Now we're going to distribute the 2 to the negative 7 and the positive 7. Okay, so what I have now, let's distribute. So if I can get my pen to work, 2 times negative 7y is negative 14y. 2 times 7 is positive 14. Then we can finish it out. 14y is equal to 4. Well, let's go back to boxes and circles on this one because I want to make sure we're looking at this thing correctly. Okay. Alright, so now if I look, I have 2 boxes on the left side. I do have 2 circles, but remember, but they are separated. I have 2 constants. They're separated by the equal sign, correct? So I can't combine these just yet. Well, if I look here, I can combine these. Okay, so if I have negative 14 plus 14, okay, what I have, guys, please remember, this is not 0y. This means this one and this one will cancel each other out. That means I'm left with just 0. It's not 0y, it's just 0. Okay, then I have plus 14 left, and then I have a 4 on this side. Well, 0 plus 14 is 14, and 4. Now, I'm going to ask myself, I don't have any more variables, so I'm asking myself, let's finish this on out. Let's go ahead and subtract this one. Right here we see it's false, remember? So it's going to be false everywhere. Once it's false, it's always going to be false. So let's move this down, and we have 0 is equal to 10. So if it was false here, it's a false statement here, which means that I have no solution. Okay? What that means is, guys, there's not a number that I can put in for x in either one of these and in y in both of these that's going to make both of these true. Now, I may find a number to put in for x and a number for y that makes this one true, but it's not the same number I can put in here and here to make that one true. So that's why we have no solution. And remember, if we graph these, no solution would be parallel lines, right? Okay? And that's all you're doing with these is just looking and seeing right here. 10 and 0, that's false. All right? One more. Let's do one. Let's see what this next one looks like. What if I was to do negative 3x plus 12y is equal to 9. And I have x minus 4y is equal to negative 3. Well, again, the first question I'm going to ask, do I have a variable that's isolated? Do I have a variable by itself on one side of the equation? Well, if I look, x and y are on the same side here. X and y are on the same side here. Well, I can't do that right now, but I'm going to look right here. Well, I have a variable that needs a 1. There's my lonely variable right here. So what I'm going to do is, since this was on the bottom, I can kind of don't have to write it again. So I'm going to get rid of this 4y. Not really get rid of it. I'm going to move it to the other side of the equation. And remember, when I move it to the other side, I want these two signs to be opposite where I can cross them out. I want them to be 0. Okay, so I have 1x is equal to 4y minus 3. Well, again, let's go ahead and just stay with what we know. Let's divide everything by 1. So I have x is equal to 4y minus 3. And again, see, it didn't change anything, but just to be safe, okay? So now I have a variable that's by itself. I know the value of x is 4y minus 3. Well, what I can do with that is take it back up here into the other equation, and we're going to plug it in right there, okay? Because it says the value of x is that. It doesn't say y, so it says the value of x, okay? So what we're going to do is we're going to take our equation. We're going to write it right here real quick, then I'll slide the board up. Now we're going to substitute in 4y minus 3 plus 12y is equal to, I think that's 9. Isn't that what it says? Yes. Okay. So let's move it up a little bit. Let's see what we got. So again, we're going to do our distribute first. So we're going to distribute the negative 3 to both the 4y and the negative 3. Okay. So we have negative 3 times 4y is a negative 12y. Negative 3 times negative 3 is a positive 9. And then finish the rest of it out because we haven't bothered anything else past the parentheses, right? Okay. So now let's do our boxes and circles. Again, I like to do these boxes and circles. It just gives me that visual of what I'm actually seeing. It allows me not to make any combinations or any combining that I can't do because of the equal sign, right? Well, if I look right here, I have a box on this side, I have a box here, which is remember it's a variable and a variable, and then but my constants are separated by the equal sign, right? But if I look here again, I have negative 12y plus 12y. Well, if you'll remember, this is going to cancel this one. What I'm left with is 0, not 0y, but just plain 0, plus 9 is equal to 9. Well, on this side, 0 plus 9 is 9. So right here, I can see 9 equals 9. I can see this is a true statement, which I'll know right now automatically. This is an infinite solution because it is a true statement, right? But I want to go ahead and finish this all the way out. So let's go ahead and move. It doesn't matter which 9 you move. You can move this one over here. It doesn't matter because you're going to end up with 0 equals 0 on both sides, which again, once it's true, it's always true. So we have an infinite solution problem, okay? So it's just taking your time, working through, and this is a lot of work. It really is a lot of work to find the answers that you're looking for, is finding that solution, okay? So just, I would like for you to, if you don't to, go back and watch it again. And again, if you haven't done the work, just kind of go back this time, and as you walk through this, kind of pause the video every once in a while and try to do the work, and then see what you can come up with, okay? All right, tomorrow we're going to try to finish our scavenger hunt, get it out of the way, and then we'll move on to elimination, hopefully either Friday or Monday, okay? You guys have a great afternoon.